Gets injections of medical drug. Each injection has 15 milligrams of the drug. The amount of drug left in Alex's body decreases by 40% each day. If you lose 40, you retain 60. That's why you have a 0.6. Is that right? Find the amount of drug left in Alex's body after 2.5 days. That is so easy because all we're going to replace the p-value with is, yeah, I'm sure that's a 5 marker more or less. So what you get, 15 times 0.6 to the power of 2.5, and it's 4.18. And lads, that's a great one to start off with, isn't it? Easy marks. They want you to pass. Okay. Now, D. How long after a single 15 milligram injection will there be exactly 1 milligram drug left? Well, the amount of drugs left, so we call the final amount is the same as, what is again, 15 by 0.6 to the power of T. And what we're going to change F to? 1 milligram. And this was the questions that you guys were dominating recently. Bring the 15 underneath. And what you do to both sides? Huh? Any log of your log, any log of your choosing. I think we're very LN happy these days. Bring the T to the front, and what do we get? ln 0.6 equals ln 1 over. And then bring the ln 0.6 underneath. And then we get ln 1 over 15 divided by 5.3, okay with us? And that meets the description of the question, 1 decimal place. Excellent work. Okay. What? Yeah, and that means this question, sorry, I'm actually on part C, which is here. This makes sense all of a sudden, because Alex is given a 15 milligram injection of the drug at the same time every day for a long period of time. Explain what the total amount of drug in milligrams in Alex's body after the fourth injection is given by. So the way I'm explaining this is that this is the fourth injection, and it's had no time to be absorbed by the body. This is the third injection, and the third injection has lost 40%, so that's why it's multiplied by 0.6. The second injection has lost 40% twice, so therefore it's retained 60% of its drug twice. Does that make sense? And the initial injection, the first injection, has been in your body for 3 full days, and it has lost 40% 3 times. So that's your first injection. Just to summarize what I just said, 15 is the amount of injection just given, which is the fourth injection. 15 multiplied by 0.6 is the amount from the injection 1 day ago. 15 by 0.6, I have to do on the outside, not that makes a difference, is the amount from the injection 2 days ago, and 15 by 0.6 power 3 is the amount from injection 3 days ago. So the total amount in your body would be the 4 Ds added together. And there's 15 or you can say there's 15 milligrams from injection just given, and the amount from each previous injection has reduced 40% each day. That is just basically re-explaining the question, isn't it? That second one for full marks. Now, we all good, guys? Excellent. Having the marking scheme there, very handy, isn't it? Now, find the total amount of drugs in Alex's body immediately after the 10th injection. I think that's essentially sounds like T1 is, let's say T1 is your last injection. Your last injection is 15. Now, can everybody understand that T1 is actually your 10th injection? T2 would be what? Your 9th injection, which is 15 by 0.6, right? And then plus dot. T10 is actually your first injection, which is, because it's there in your system for 9 full days, and then so that's what we're looking to get the total of. Now, it's a lot of effort to type all that in individually, so we're going to do the SN form, aren't we? So the geometric series, we're going to go SN equals A 1 minus R Rn, isn't it? All over 1 minus R. You see the way I like to go in reverse, so that the lowest power is at the, You don't necessarily have to do that. I'm sure if you looked at the marking scheme, it might be the reverse. No, it's not actually. They did it the same way, just with no explanation. Okay, there we go. Now, here we go. What's the A value? 15. Your 1. What's your R value? Financial maths actually makes this easier, doesn't it? And 1 over. It is, thank you. Funnel saved me. I got mixed up with the power. There's 10 separate payments, so to speak, isn't there? So it's actually to the power of 10. That's a mistake we could all be prone to making, okay? So it's the power of 10. That's over 0.6. And what do we get here then? Fraction button 15. 1 minus 0.6 to the power of all over. So 0.4 on the bottom. Because 1 minus 0.6 is 0.4. You've got 37.27 milligrams in the system. Okay, and we'll see what the correct is with the result. Yep, 37.27, and that was a 10 marker. Using your formula with some substitution would get you 3 out of 10. Just writing down the SN formula and trying to sub something in. And obviously, if you're fully substituted, you get 7 out of 10 for that. We cool? Now, next thing. Part A. Is it E now? Is it wrong? Okay. Use the formula for infinity. It means we're going to keep adding on for forever. And there's a formula for S infinity. Do you remember the formula for S infinity? A over 1 minus R. And what's A again? And our R value? Minus 0.6, yeah. And this is the limit to how much we can keep in our system. And we get 37.5. And once again, we're just going to quick peek at the marking scheme. 37.5, yeah, that's a 5 marker. And now there's a part F we're going to have to look at now as well. Zoom. Okay, let's keep going down. Jessica gets daily injections of a medical drug and at the same time every day. She gets D milligrams, where D is an element of R. So D is some sort of decimal maybe. It could be like 3.75 or 4.86, some random number. Could be 10, could be 5, I don't know. Okay. The amount of drug left in Jess's body injection increases by 15% each day. It's a decreasing series. Okay, so imagine this. It'll be D by 0.85 to the power of how many days you're in the system. Does that make sense? You're losing 80, you're retaining 85% because you're losing 15. And that explains our 0.85 N. Now we're going to use a geometric series, right? Your latest injection, which would be Tn, which is the injection you just got. How much is left in your system right now? D. All right? Now, how many days is she getting for? Does it say? No, it doesn't say. It doesn't say. So leave it big. Okay. No idea. Just let's keep going for a minute. Your second last injection, how long is that in your body for? 1 day. It's 1 day in your body. So what's that? D and 0.85. It's all right. We're good. I know where the 20 and the 3 come from now. It's all good. I just figured it out. Okay. Now, what happens in your very first one? Your very first injection. Sorry, I think I have this the opposite way around. You'll have to excuse me for a second. T1 is your last injection. T2 is your, and Tn will be your very first. And how long is that in your body? N minus 1. Because you remember in the last question, it was in your body for how long was it in your body for the last question? It was oh sorry, I have to go all the way back here, don't I? We did 10 injections, but the last one was in our body for 9. So if we do n injections, it's in your body for n minus 1. By that logic, right? Now, I don't think it's going to affect us too much anyway. Getting that last term right, I don't think it's going to affect you anyway. So what's Sn? 1 minus n all over. Now, Sn, now what's A again? D. What's 1 minus Rn? 1 minus, and R is 0.85, isn't it? Okay. And here's the kicker, right? Here's the part where oh, sorry, I got that wrong. The n is on D, and there, yeah. And 1 minus R, 1 minus 0.85, all right? Now get this, all right? Here's the kicker. I'm just going to put this into my calculator. See all this? See all this part? I can highlight that part in my answer. There it is there. What I'm after is the 20 over 3. So technically, it's this part here, which has nothing in it, and this part here. So it's actually 1 divided by 1 over 0.85, which is actually 1 divided by 0.15. And that gets you 20 over 3. And now we've got exactly what we were looking for. So yeah, go on. Do you want me to go again? Immediately, do you know what the great news about this one is? If you didn't get part 1, you can still do part 2. So I'm going to get the formula for part 1, which is this formula here, yeah? Okay. And we all agree that this is the great thing about the Leaving Cert these days. Just because you get ruled out of part 1 doesn't mean you're ruled out of part 2. If you really read the questions precisely, like anybody could get 10 marks for this one here. Right. Just pretty much the last question of the whole thing. Now, the question is, we're after D, aren't we? But the whole thing has to equal 50. Why? There's 50. N is equal to 7. So 50 equals 20D, 1 minus 0.85 to the power 7, close bracket, all over 3. Now here's what I do first. See the 3 on the bottom? Yeah. Multiply that by 50. What you get? 150. See that 20? Bring it under. Neat. See that 1 minus 0.85 to the power 7? Bring that underneath. Throw it all into the calculator. And let's find out what D is. So just to recap, okay? I brought the D is what I want on its own. The 20 went underneath. The 3 went up to the 50 to make 150. The 1 minus 0.85 to the power 7 was multiplication on the right, so it's division on the left. And you throw that all into the calculator. How many decimals? Nearest milligram? 11 to the nearest milligram. And if we look at our marking scheme here, that last question was only worth 5 marks, but actually the part 1 was worth 10. So any work of merit identifying A or R in the previous question would have got you 3 out of 10. So